a small quiz, and I'm going to be doing these a lot in this chapter just to make sure you're learning the things and not forgetting the things that we need to know along the way. So if you learn it the first time, it's a lot of easy quiz points. Your quiz tomorrow is going to have two things. It's going to have this table and a blank circle. So essentially, you know exactly what it is. I'm going to do it with you today, and tomorrow you will have to do it. This table, it's really all stuff we've done before. The only new component on the table is this radians column. So we are going to talk about our common degree measures, just sine, cosine, tangent. As
I'm so sorry.
Fine.
I forgot you said the acronym on my marker.
So you just run around school with this is telling them. Quiz tomorrow. Two things on it. This table and the unit circle. And I'm going to go over both with you right now. So. Okay. Now this radians piece, on your quiz tomorrow, you could get the radians here, or if you like filling out the circle, you could get the circle first and then copy the radians down from that. To get the radians, we can convert it by taking it times pi over 180, or hopefully eventually we'll get to the point where we just know them. But if I did 0 times pi over 180, we just get 0. If I take 30 times pi over 180, so 30 over 180 would give me pi over 6. 45 times pi over 180. 45 over 180 reduces to 1 over 4. 60 times pi over 180 gives me pi over 3. 90 times pi over 180, pi over 2. 180 degrees, pi. 270. 3 pi over 2. 360 all the way around the circle.
Well, actually, no.
Yeah, technically it's 2 pi, but it's coterminal with 0, so they're at the same position. Okay, so that's the radian bit. Then the next sine, cosine, tangent, that's just your hand trick. So sine of 0 is 0. Cosine of 0, radical 4 over 2 would be a 1. Tangent, radical 0 over radical 4 is 0. 30 degrees, sine, radical 1 over 2. Cosine, radical 3 over 2. Tangent, radical 1 over radical 3 will give me radical 3 over 3. 45. Sine of 45 would be radical 2 over 2. Cosine 45, radical 2 over 2. Tangent, radical 2 over radical 2 is 1. 60, sine is radical 3 over 2. Cosine radical 1 over 2 is 1/2. Tangent, radical 3 over radical 1 is radical 3. 90. So sine radical 4 over 2 is 1. Cosine square root of 0 over 2 is 0. Tangent radical 4 over radical 0 . Okay, for the 180 and the 270, you might need to go back to this picture like we did in chapter 1. In this picture, the r was always 1. My x is -1, my y is 0. So sine, we knew was y over r, so 0 over 1 is 0. Cosine was x over r, so -1. Tangent y over x is 0. .270, this is like the point 0, -1. So sine y over r is -1. Cosine x over r is 0. Tangent y over x, -1 over 0. Undefined. You'll notice like 0 and 180, they're similar except for the 1 becomes negative. 90 and 270, same thing. Got the same values except your 1 is negative there. 360 is the same as what? 0. So you already know the values for 0. No need to recalculate them. It's coterminal. They are the same. Alright, so that's the table. All things that we have seen before just kind of put into one table. Any questions on that? Okay. I want to practice filling out a circle with you. I know you've already filled this out, so you don't have to copy this down. If you think you would like a blank one to practice on before the quiz tomorrow, there are blank ones on my desk. You're welcome to grab one today if you need that. To get our degree measures, we start at 0 and then it's just the common angles from our hand trick. So 0, 30, 45, 60, and 90. And make sure you're putting your degree symbol. Jump down here, and what is this line? 180. Then how did we get these? Okay. So 180 minus 30 is 150. 180 minus 45, 135. 180 minus 60 is 120. You can grab one if you want. Okay, what do we do in the third quadrant? So 180 plus 30, 210. 180 plus 45, 225. 180 plus 60, and 180 plus 90 is 270. How did we get these? So 360 minus. So 360 minus 30, 330. 360 minus 45, 315. And 360 minus 60 is 300. Alright. Could you guys do the degrees?
Yep.
The radians, technically, you could get it if you just went to every degree measure and multiplied by pi over 180. But we're trying to get faster with this. This isn't like a whole class period quiz that I'm giving you. This is, 5-10 minutes. So we need to kind of be a little more familiar with these. Let's talk about the first quadrant first. 0 times anything is 0. I also told you that if you called this 360 degrees, that would be fine. Or 2 pi. So you don't have to have both of those, just one. I don't care if you use the 0 or the 2 pi. Then in the first quadrant, remember, it was always just pi over something. And as we went up, those numbers got smaller. So it was pi over 6, 4, 2. Good. Let's jump down here. 180 is the same as pi. 270 is, okay. Then we can use those patterns we talked about yesterday. All 4 of these have a reference angle of 30. When the reference angle was 30, it was always something pi over 6. Okay, we'll come back to do the numerators here in just a second. Then, moving out, all of these were a reference angle of 45. And 45 is pi over 4. So all of those will be something pi over 4. And then all the 60s are pi's over 3's. Okay, so with the reference angle, I know my denominator for all of those. Then, we just need to know the pattern. In the second quadrant, the numerator is 1 less than the denominator. So this would be 5 pi over 6, 3 pi over 4, 2 pi over 3. Third quadrant, the numerator is 1 bigger. So that's 7 pi over 6, 5 pi over 4, 4 pi over 3. What was the pattern in the fourth quadrant?
Double minus 1.
So 6 times 2 is 12, minus 1 is 11. 4 times 2 is 8, minus 1 is 7. 3 times 2 is 6, minus 1 is 5. And we filled out our whole circle. Yes, ma'am.
So all you would really need to know for this is the patterns in the first quadrant.
And if you forgot the first quadrant, you could get it just by multiplying by the pi over 180. Question 6. So you know exactly what your quiz looks like tomorrow. I really just screenshotted this from the top half of the quiz and the bottom half of the quiz. So this is exactly what it looks like. For the rest of class today, first you have an assignment to work on. I'm probably going to stop you with about 10 minutes at the end of class, and I'm going to start the next section. I won't get too far. I'm not going to give you any homework out of it, but I just wanted to do an introduction to that. So you have quite a bit of time to work, and then we will stop at the end of class and do some notes with this radian measure. And we're going to be doing a couple different calculations in this. So we'll just talk about the first one today and maybe do a couple examples, and that will be a good stopping point for tomorrow. We've already seen S equals r theta. Well, sorry. We were talking about to find an angle in radian, we did theta equals S over r. I wrote that down yesterday, and we did one example. I think they used that. If you multiply that r to the other side, we get the formula that we are focusing on today. S equals r theta. S meaning arc length, so that's the distance on the outside of the circle. So the distance a point travels on the outside of a circle can be found by multiplying the radius and the angle. However, for this to work, the angle has to be in radians. If you use a degree measurement, you will get the wrong answer. So essentially, the bigger your angle is, the farther your point is going to travel. They're proportional to one another. We're just going to do some basic calculations with this. So a circle has a radius of 25.60 centimeters. So that's my r. Find the length of the arc. So arc length, that is S. That's what I'm looking for. Intercepted by a central angle having each of the following measures. So part A. If my angle is 7 pi over 8. So if we did S equals r theta, my radius is 25.6. My theta, my angle is 7 pi over 8. 25.6 times 7 over 8. You could answer a couple different ways. If you don't multiply out the pi, you get 22.4 pi. If you did multiply it out, that's like 70.3717. I do expect units here. S is a distance, just like your radius. So my radius was in centimeters, this would be in centimeters. For B, my angle is 54 degrees. What's the problem here? It's in degrees. My formula only works in radians. So what would I do?
Multiply by pi over 180.
Right. We want to get rid of the degrees, so they have to go on the bottom. We use the same conversion as today. So 54 over 180. So we get 3 pi over 10. So then you can do the S equals R theta. Radius is still 25.6. Theta is 3 pi over 10. So you get 7.68 pi. Or if you multiplied out your pi, that's 24.1274. Typically I leave my answer in terms of pi, but you really could answer either way. Any questions there? I think I can go ahead and do this, and then this will be my last example. Erie, Pennsylvania is approximately due north of Columbia, South Carolina. The latitude of Erie is 42 degrees north, while that of Columbia is 34 degrees north. Find the north-south distance between the two cities. So, we know something. I think we can all agree that the Earth is round, right? Okay. Hopefully nobody's going to argue with me there. If I gave you the latitudes for these two cities, but all I'm really needing is the angle between them. So what would I do to find that angle? I want the distance between them, so we would subtract those two measurements. So 42 minus 34 is 8. So my angle is 8 degrees, but can I use that? No, so multiply by pi over 180. And let's see. 2 pi over 45? Okay, I gave you the radius, 6,400. I want the north-south distance, so I'm looking for this distance on the outside of the circle. That's my S that I need to find. So it's again just an S equals R theta problem. 6,400 times 2 pi over 45. This one, I'm going to go ahead and multiply out the pi, because if you're going to give me a distance and I'm going to measure it, I probably need the full number. What would my unit be here? Kilometers. It'll always match your radius.